In the year 1971, the Hafele-Keating experiment was conducted, in which 2 atomic clocks were placed onto planes, and 1 clock was kept stationary at a lab in Washington. Now, these were not just ordinary clocks, these were atomic clocks. The difference between an atomic clock and an ordinary clock is that while an ordinary clock will count based on seconds, an atomic clock is very, very precise, because an atomic clock will determine time based on the vibration of atoms. The atomic clocks that were on the planes went in 2 different directions. One plane went east, the other plane went west. And the results of this experiment were really interesting, because what they showed was that the east moving plane actually lost time on the atomic clock, and the west moving plane gained time. The first thing you can pull from this experiment was that the motion of an object directly affects the rate of change of the time that that object experiences. But there was a question. Why is it that the west moving clock gained time? I mean, if time dilation occurs, shouldn't both clocks that were on the planes have lost time? Well, there's a very important factor being left out of all this, and that factor is gravity. Basically, the western plane was actually a bit higher in the sky than the eastern plane, and because of that, the western plane was actually experiencing less time dilation from Earth's gravity than the eastern plane. And it was also experiencing less time dilation than the stationary clock, because the stationary clock was both experiencing the full force of Earth's gravity, and it was also experiencing the motion of the Earth rotating. So although the western plane was moving just like the eastern plane, the western plane experienced less time dilation.